So, I forgot to put the videotape on for what we just discussed, so I just want the video to record this answer, so if you go home tonight and you look this over, you can look at this and follow everything along, okay? Now the graph. Y equals 2x plus 1. Here it is. What's the slope, guys? 2 over 1, sure. And what's the y-intercept? 1. So I begin here at 1. I go up 2 over 1, up 2 over 1, up 2 over 1. Fill in the backside a little, connect the dot. Make sure you write the name of the line on it. You were much better at that today. Much, much, much better. Then, this one, we seem to have some problems with. Some people had a really hard time with a slope of -3. And I saw slopes of 1/3, and I saw slopes of +3. No. Remember, positive slopes go up, negative slopes go down, 0 slopes are right in the middle, no slope is vertical. Now, here the y-intercept is 6, so you begin at 6. We were good at that. But if the slope is -3, you're going to go down 3 over 1. Down 3 over 1. Down 3 over 1. I saw a few people who went down 1 over 3. They ended up over here. And that would be a mistake. I draw the line, and I notice that they connect or intersect at the point 1, 3, and I saw lots and lots and lots of people writing the coordinates of the point of intersection. That was excellent. You guys really learned a lot from yesterday. And this one you didn't have to check, so that's all you needed to do. Okay? Any questions? Preguntas? Good. So, if you continue to improve tomorrow the way you improved today, you should be in fantastic shape for excellent grades. The grades today were pretty good, and I think they'll be pretty fantastic tomorrow. All right, so we've been talking about the solving of systems of equations, and here is one for you to do when you do it. Now, I say this all the time, but it is so important that your do it is done while I grade the quizzes. I know that sometimes some of you don't do your do it, and that's a big, why don't you have your sheet out, Spencer? That's a major mistake if you don't do it. Everything is meant to fit together, so every type of problem is covered. Did you notice how on the quiz for the last 2 days, I've given you quiz questions where the middle numbers, the y's, one was positive and one was negative? Did you notice that? Okay. That's not always the case. That's the easier case. The harder case is where the signs are the same. Now take a look at your do it question. Do it question, the signs are the same. So I want to make sure that you're doing everything, because between all the types of questions, all the variations that you could be expected to know will be covered. Ethan, let's pick your head up, bud. So, I can pair up either letter here. I can pair up the x's or the y's. Which one do you think is easier to pair up? The y's, definitely, because one of them is already a 1, and the other one's 3. So all I got to do is multiply by a 3 to match up the same value of 3. But, and here's the big but, it has to be a -3. Because when I multiply by that negative, I'm going to make the y negative. Watch what happens. -3 times 3x is -9x. -3 times y is -3y. And -3 times -12 is +12. That negative sign serves to change every sign. And then here, I just stay with 2x plus 3y equals 9. In other words, this bottom one, I'm not changing anything, because now the 3y's match up. By using the negative on the 3 here, it makes that a -3y, and now I can just add them up. What's -9x's and +2x's? If it's -9x's and 2x's, it's a -7x's. Die, equals 12 and 9 make 21. Divide by -7, x is -3. Okay?
Wait, I don't understand. You change change the 3y into negative 3?
Yes, I got the 3 part by multiplying by 3, that I think you understand. But, since the signs were the same, if I added them up and I kept it positive, that would just give me 6y.
So you just,
That wouldn't do me any good, so by making it negative also, not only do I get the number right, but I change every sign.
so you could change the,
You can always put a negative in there to change signs, okay? Now, next step. I gotta go back and get y. Spencer, make sure we show our work like this tomorrow, right? 3x plus y is negative 4. You can write over either equation, it doesn't matter which one. X is negative 3, so I go 3 times negative 3 plus y is negative 4. Negative 9 plus y is negative 4. Add the 9 to both sides. Y is 5. So I get x is negative 3 and y is 5. Any questions? If you can do the quiz question plus this question, the first quiz question, plus this quiz question here, or do it question, you can handle pretty much anything I can throw at you with the elimination technique. All right? So I think that you're in great shape if you can do those two. You are just about perfect on the topic. All right, now, let's talk about the substitution technique. That's what we did yesterday. And the big thing about the substitution is this. Do you know how with the elimination it always looks something like this? I get my x's over my x's, my y's over my y's, and my equals a number over equals a number. When you recognize that pattern, that's when you use substitution. I could put it to you this way. When a quarterback in football comes up to the line of scrimmage, he's looking at the defense, and he's saying, what's the correct play to call for this defense? If we call the correct play, there's a really good chance it's going to work. Or, I think I mentioned in class yesterday, the kid John Weiler, who used to wrestle for me, he had 2 great moves from his feet. One was a fireman's carry, the other one was a low single. If the guy came with the arm out, he did the fireman's carry. If he pulled the arm back, he did the low single. So, depending on the situation that he saw, it determined his strategy, his course of action. So if I see this, where the x's are lined up, the y's are lined up, the equals numbers lined up, I'm saying, oh, I got this. This is elimination. And honestly, based on what I just graded on your papers, it looked so good that well over 3/4 of the class is very good at solving those. Okay? Now, we have a whole new different skill to learn. And the reason is because if you look here, you don't have x's over x's, y's over y's, equals number over equals number. I get 3x plus y, 5y is 14, and then x is y plus 2. When I see something like this, an x is y plus 2, or a y is x minus 5, guys, if I see something like that, to me, it always means that I have to use the substitution technique. And the best analogy I can possibly draw for the substitution technique is to say this. If I went to a soda machine and I wanted to put $1 in the soda machine, and the soda machine was chock full of dollars and it wouldn't take anymore, how could you still get a soda? Right, trade the $1 in for 4/4. So this is telling you what an x is worth. An x is worth y plus 2. So now I'm going to rewrite the top equation. I'm going to write the 3, I'm going to write the plus the 5, the y, the equals, and the 14, but I'm not going to write the x. The reason I'm not going to write, guys, you are not paying attention, and you will not learn if you're not focused. The reason I'm not going to write the x is because directly underneath it, it says the x is y plus 2. So instead of the x, I'm going to put y plus 2. And now, what I have on the board there in blue looks like an equation that I would have given you around October 1st. So we've been doing these on every test, on every homework, since around October the 1st. So you should be really good at this. Distribute the 3, 3y plus 6 plus 5y is 14. Is this a same side situation or an opposite side? Same side. So 3y's and 5y's add up to 8y's. Plus 6 is 14. Now I minus the 6. 8y is 8. I divide by 8, y is 1. Am I done? No. And there's something really cool about problems that are substitution problems. The really cool thing is, because it says x equals, I can just plug it right into that. X equals y plus 2. What did we say that y was? 1. So it's 1 plus 2, x is 3. Hold on. I've got y is 1, and I've got x is 3. Okay? What do we call this technique?
Substitution.
How do you tell if you're going to use substitution or elimination? Rich?
If the variables line up,
Yeah. If everything is lined up straight on top, you use
the
elimination.
elimination.
And if you see something that says x equals y plus 2 or y equals 3x minus 1, if you see anything that looks like that, then you use substitution. When you see one variable is, and then it puts it down. Now, what I want you guys to do next is the question directly under there, and I would like you to work with somebody you're sitting around, work it out together. Let's see how you do. After this one, we have one more to do, which is individual work. And I'm going to have to change that second one in a minute. Okay, go ahead. I don't know if Max off, yeah. I don't know if you know it or not, but Max is a pretty sharp kid. I'm sorry, I didn't know that. Oh, no, right at the end. You just put in the n minus 3. So it's 3 parentheses n minus 3. Okay? Chris, come on, hit the game, buddy. You did an awesome job on your quiz. Let's keep it pushing forward, and then we're gonna get a great job on your test. And that means you are in super shape to pass what you want here, right? Remember how before I had to stop you from talking to students? Now you can talk to students about math. Yes. Nice try. Sweet. 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 Right there. That's awesome. Now you gotta go back and get in though. Right? But to get in. But it's really easy. It just says n is n minus 3. So put the 4 in for n, it's gonna be 4 minus 3. Right? Are we good?
Trying to get my location of where I am.
Hold on, Rich.
Over here, more.
Okay, now hold it. I want to go through this, and I got to tell you, Anthony just absolutely made my day. He did such a fantastic job on this particular question. You know what it means to me? I don't know if you know this or not. I want to talk for a second about where kids screw up. Kids are liars to themselves. You lie to yourself all the time. Oh no, you absolutely do. And the way you lie to yourself is you take the easy way out. And one of the great ways you do it is by you convince yourself all the time that you can't do certain things. And the truth is that you could do them if you were willing to pay the price for them. Here's an example. If I line up 100 kids, and I look at the relative math abilities of those 100 kids, you might get anywhere from 5 to 10 of them who are just that smart. They really are. They're just that incredibly smart that they see things once and they get it. And I might get 5 to 10 of them that really, really do struggle. And math is very, very difficult for them. And then there's 80 to 90 in the middle, of which you are one. And those 80 to 90 in the middle, how well they do will all depend on how hard they work. There is no way that you understand this after the brief amount of time we've spent on it if you don't work. So it's obvious to me that Anthony worked. And, you know, have you ever had a teacher that you look at and you're like, man, that's a lazy teacher and they don't care and they don't work hard? Don't mention names, please. Have you ever had someone like that? Okay, if you have someone like that, one of the things that happens to teachers over time is they do what's wrong, exactly what you did that would be wrong if you believed you couldn't do the work. Therefore, you don't do the work. If a teacher says, well, I can't get that kid to be better, I can't get that kid to learn, and they say, therefore, I'm not going to try, and they don't work hard. Now, I'm sure you look at a teacher like that, like, with just no respect. Now, likewise, if it's your life in your hands, and your future in your hands, and you come in and you look at the stuff and go, I don't get that, and then you don't want to work hard to get it, well, you're as bad as that teacher. And I can only imagine the anger that you have had toward teachers like that over your life. And I would then say that if you are the kind of kid who refuses to work, then you should also have an equal amount of such anger toward you. Okay, let's take a look. Ready? We see right away that the m is equal to an n minus 3. So I am going to substitute the n minus 3 for the m. That's the critical step that you have to take. If you can see that step and make that happen, everything else you know how to do. Just distribute the 3. 3n minus 9 minus 7n equals negative 25. How many n's do I have here altogether? 2. No! I have positive 3 n's and negative 7 n's. Negative 4n. Minus 9, danger, 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 don't lose track of that, equals negative 25 plus 9 plus 9, die, die, negative 4n equals negative 16. Divide by negative 4, die, die, n is 4. Now, you've done all of the heavy lifting. All of the really hard stuff in this problem is finished. The beautiful thing about the substitution technique is that if you get to this point where you know n is 4, it's always so easy to find m. I just rewrite it, take the 4, dump it in for n, and what is 4 minus 3? 1. Okay. And Spencer, when we get to the next quiz after this, or the one after that, I can't remember which, you know that I'm going to give you a substitution to do, so make sure you show work like this to get that second variable. Okay? All right, any other questions? All right. Now, whatchamacallit? We are to the point where the period is just about over, so I'm not going to start a new one. But you guys look very, very good. I think you're on the cusp of kicking some serious butt in this stuff. Keep it up. Keep rocking it. Remembering when to use elimination and substitution.